The lesson topic for this video is I can factor. And the two types of factoring we're going to work in this video are GCF and when we factor quadratics when a equals 1. So these are actually two very different types of factoring, but factoring in general is the same idea, and we're going to talk about what that means by looking at this vocab right here. First of all, I need you to understand that a term and a factor are different things. Okay? A term is the parts of an expression that are added together. So if you look down here, I have three different expressions. This is an expression right here, 3x. It is a single term, one term, so it's a monomial, and it has two factors. So now let's talk about the word factor before we carry on. A factor is a number or a variable that when it's multiplied with another one, produces a given number or expression. So here's our expression, 3x. Again, has a single term. Each of the parts of that are factors. So here's the key. Terms are things that are added together, and factors are things that are multiplied together. So 3 is a factor, and x is a factor, because they're being multiplied. Together, it is a term. In this expression right here, we have two terms. When we have two terms, okay, two things that are being added, or in this case subtracted, same idea. We have two terms, it's called a binomial. Bi meaning two terms. Now, in this one term of that binomial expression, in this 7x term right here, we have two factors. 7 is a factor and x is a factor. In this 8 over here, or technically negative 8, there are also factors of 8. And that is, again, things that multiply together to give me 8. Well, we know 1 times 8 is 8, and we know 2 times 4 is 8. So 2 and 4 are both factors of this as well. This is a trinomial. A trinomial, tri meaning 3, has 3 terms that are being added, again, or subtracted. So this is a term, and this is a term. In each of those terms, we have factors. In this term right here, we have a factor of 4. And since 4 has factors 2 times 2, 2 is also a factor of this term. And then we have x to the third, which is another factor. And we can also think of x to the third as x times x times x. So if we break this down into simplest factors, or lowest terms, we have 2 times 2 times x times x times x for this term right here. So this is a way we can sometimes list all of the factors of a term. 2 times 2 is 4, x times x times x is x to the third. 2 times x squared, this term has, again, factors in it, and then so does this term as well. So, okay, enough with that vocab for now, but more practice with that in class. But now we have to focus on GCF, the greatest common factor. Now, the greatest common factor simply means that it is the largest factor that is common for 2 or more terms. So we're going to look at some examples on the next screen, and you've done this before, about how to factor out something that is called the greatest common factor. Okay, so you've factored out GCFs before, so this should look familiar, and if you need more help with this, definitely ask in class. So if I have 4x plus 12 right here, all right, I'm looking for the greatest factor that is in common between both terms. I'm going to start by just looking at the number factors, 4 and 12. Are they both divisible by the same number? Yes, they are. They're both divisible by 4. So that means that is a common factor. X is a factor of this term, but x is not a factor of this term, so it's not common. So then what we do is we just put our parentheses back down. If I started with 2 terms with a plus in the middle, I need to end up with 2 terms with a plus in the middle. And the only reason that's ever different is if you factor out a negative, which we will talk about later. And we just say what's left if I've divided out or factored out the 4. So since 4 divided by 4 is 1, we have a 1 here, which we don't have to write, and the x stays. Now we would have to write the 1 if that was the only thing that was left, but there's an x that remains. Then 12 divided by 4 is 3, so we need a 3 here. At this point, we're done with this problem. We've factored it completely, and if you wanted to check that, all you'd have to do is distribute the 4 back in to see if you arrive at this. 4 times x is 4x, 4 times 3 is 12, and the plus is there. We have factored out the GCF. In our next example, we have x squared minus 3x. So there's obviously no numerical GCF because this is a 1 and this is a 3. We're not going to ever factor out a 1. There's no point in that. But there is a common factor of x. Now think about x squared as x times x. So how many x's are in common with this term and this term? The answer is 1. There's one x that's common in those two terms. So I can factor out an x. Again, two set of parentheses are left with a minus down here. And what is left? Well, we had two x's being multiplied together. One of them was divided out, so we're left with x. And then we had 3x, and we factored the x out, so we're left with 3. Okay, why don't you go ahead and try this last one on your own, and there's a hint. You will factor out a greatest common factor that's a number and also a variable. Okay, now it's been a while probably since you've thought about factoring quadratic expressions. So this right here is a quadratic expression. Quadratic equations or expressions are those that have x squared as the highest value for our variable, or highest power for our variable. So if you ever have an x squared in an expression, which we do here and here and here, we are dealing with a quadratic. All right? A lot more about quadratics as we carry on in this course. So we're going to talk about factoring quadratic expressions when our a value is 1. Our a value is 1. So this is where a is found. All right? And when that is a 1, if you think about it, if that was a 1x squared right here, you know that we don't usually write that 1 in. We'll just write x squared. So, as you see right here, we have 1x squared and 1x squared and 1x squared. So these are all examples of factoring quadratics when a is 1. So how do we do this? Well, factoring a quadratic means that we need to find the two factors that multiply together to get us this. Okay, two factors that multiply to get us this. And what those two factors are going to look like? Well, almost always they are going to look like two binomials in parentheses. Okay, once I kind of start showing this, I think you're going to remember. We need to find two binomials that when multiplied together gives us this. Now, I'm going to back up just a step and remind you about something. What if I had x plus 2 times x minus 3? Do you remember how we multiply binomials? Well, you might be remembering in your head right now this term called FOIL. First, outside, inside, last. We multiply the first terms, so we multiply these two. Well, x times x is x squared. Then we multiply the outside terms, so these two terms, x times negative 3, which is negative 3x. And then we multiply the inside terms, 2 times x, which is 2x, positive 2x. And L stands for last. We multiply these last two terms, so positive 2 and negative 3, and that is minus 6. Then we can combine any like terms that have the same variable part, and that's the negative 3x and the positive 2x, and simplify to get x squared minus 1x, or just an x, and minus 6. So notice, we just arrived at a trinomial that looks just like these. X squared minus x minus 6. And how we got here is by multiplying two binomials. So that's what we need to do. We need to fill in our two binomials so that if we FOILed this, we would get back to this expression right here. Now you might see here that this negative 6 comes from the fact that these two things multiplied together gives us negative 6. But the middle term we have to be careful of because we need to get a negative 1 here by adding two things to get the negative 1. Which means we need to be able to add these two terms, those two terms, to get a negative 1. So the goal here, we need to find two numbers that multiply to give us this, and they go here, but the two values we use need to add up to this term right here. Okay, so the numbers that multiply together to give me 7. I'm going to write those right by my 7 right here. So 1 times 7 is 7. And there is one other option, and that is -1 times -7. Now there's no other factors of 7 because 7 is prime, so there's not like 2 times 3 like there is for 6, but we do have our options there. So which of these options adds up to +8? Well, the negative ones don't, but these two do. They add up to 8. 1 plus 7 is 8. So we now know that our factors that we have to use are x plus 1 and x plus 7. If we were to FOIL this right now, we would get x squared plus 7x plus 1x from the middle two terms, so 7x plus 1x, which is 8x, and then plus 1 times 7, which is 7. So this is the correct factored form for that expression. Now how about this next one? First thing you always want to pay attention to as things get more complex is we have to make sure that we see what number there is here for a. Since there's no number out here, it is a 1, so we can use this pretty quick factoring method. So we're going to put 2 sets of parentheses down and find out which 2 binomial factors will work here. So I'm going to start by finding my factors of -10, the things that multiply together to give me -10. Well, I know 1 times 10 is 10. But one of those two has to be negative in order for it to be -10. I'm just going to put it in the front for now. I also know that 2 times 5 is 10. Okay, but again, one of them has to be negative to give us -10. Now our job is to think about which of those two factor pairs adds up to this -3 right here. Well, -1 and 10 add up to 9. So that's not it. And -2 plus 5 adds up to 3. Well, that's close, but we need it to be -3. Well, here's where that negative symbol can be changed. We could change it so that this 5 is negative and the 2 is positive, because that's still going to multiply to give us -10. Now what do these add up to? Well, now they add up to -3. And that is what we need them to be. -3. So now our factors are x plus 2 and x minus 5. And we get those factors, I hope you notice, from right here, plus 2 goes here, and minus 5 right there. If we multiplied this by FOIL, we would get back to our original expression. Check it if you are interested. Okay, so before we do this next one, I need you to fix something. Okay, this is actually going to be a plus sign right here, not a minus. All right, so we have x squared minus 7x plus 12. All right, again, notice that the leading coefficient, the a value, is 1, so we can use our shortcut method of factoring, our quick method, and we are going to start by listing the factors of positive 12. So 12 is 1 times 12, or 2 times 6, or 3 times 4. Now, I hope you notice how important it is to know what numbers multiply to give us other numbers. So we need to know the factors of 12. All right, so which of these then adds up to -7? Well, 1 plus 12 is 13, so that's not it. 2 plus 6 is 8, so that's not it. And 3 plus 4 is 7, and that's actually not it, because we need -7. So there's another set of options. Remember over here we said it could be negative and negative, because a negative times a negative is positive. Okay, well that is our other options here. We could make all of these negative, and since we know that this right here added, 3 times 4 adds up to 7, we know that if we made both of those negative, -3 and -4, they will now add up to -7, right? But they also still multiply to give us positive 12, because a negative times a negative is a positive. So we found our factor pair, and we're going to go ahead and write x minus 3, x minus 4. Okay, now try these on your own.